Thank you very much for kind introduction, and thank you for attending all audience, and thank you for giving me this kind of wonderful chances to talk in front of all of you. So what I'm gonna talk is gonna be the quantum education required by industry. Actually, it's a title given from Professor Eunseong Kim, but just listening to what Dr. Ju just gave and what Professor Lee mentioned, it seems like what I have to talk today is, and the content that I have today is about kind of in-house grown workforce in the industry and like kind of workforce in wild, because we have some like PhDs in quantum industry and quantum technology, but we have studied internally without any fund from government. It's all kind of homegrown kind of workforce. So in LG, we have several teams in LG companies. Actually, I'm from the LG Electronics, but the organization that I'm in is AI Lab, and I'm actually leading two divisions. One is AI perception, it's about the AI, and the other one is quantum. But in LG companies, in LG Group, we have more companies like, as you know, LG Chemicals, LG Display, LG Energy Solutions, and LG Innotek. There are a lot of companies, and we are the only LG, the dedicated quantum research group in those LG companies. And we call ourselves as LG Quantum, and kind of representing all the kind of quantum researchers in LG companies. In other words, we are paying for this quantum R&D fund for every other companies in LG groups. So what you have to do in company is to solve business-related problems in LG. So it's I think it's a unique mission that we have. And also, we have to do some contribution to the quantum society. And actually, there are some kind of hidden word behind that. To solve business-related problems in LG, what you have to do is that we have to explore the value, even before the fault-tolerant quantum computing era. Some companies will claim that it's going to be like a couple of years later, but some companies told it's going to be like 10 years later. Some people say it's going to be never, but you have to find the value before the era. So as you know, that's going to be something like exponential speedups, or these days we call it as like quantum utility. And we always mention that the mission that we have to find out of our research is that we have to find quantum utility or practical quantum advantage. That's what we have been claiming for. And it seems like this is something that is being claimed as well from other companies as well. And for the quantum society, we have to build. Well, we are learning that we definitely need full tolerant quantum computer in the near future, in the future, but we have to build continuous path toward FTQC, but starting and using with currently available hardware and softwares, which needs computers today. Because I'm from the corporate, and actually we don't have tomorrow, so I have to do something for today, but tomorrow. Otherwise, if we prove ourselves, the value of ourselves, and value of our research, then there are always there are changes in the corporate. So we do a lot of researches in the companies, again, to solve business-related problems with exponential speedups or quantum utility. And that's why we have been collaborating with companies and universities, as you can see in this slide. So, well, we are working very closely with IBM and Pascal, and other companies and universities as well. And actually, we have teams in Korea, Japan, and Canada. The problems that we are interested in to solve should be directly related to our business portfolios. And as you know, LG is kind of one of the top companies in home appliances, which means that we have really great refrigerator, washer dryer, and televisions and robot and other kind of consumer electronics. So we have to find the usefulness of quantum technologies in such business portfolios. So that's why we are interested in quantum-based CFD, problems, and that's why we are interested in optimization problem, and that's why we are interested in material discovery problems for our display or battery. Also, we are working on the quantum machine learning because AI, machine learning is really it's a big these days. So we have to find a way to combine those quantum with classic and legacy AI machine learning technologies. So in my team, actually I had my team, I have a photo of my team members, but they claim that it's kind of breaching their portrait right, so I just erased that. But anyway, so I have a team with quantum technology experts, and they are mostly PhD graduate in quantum information science, quantum chemistry, and quantum physics. But we also have quantum engineers in practice, which means that they have other majors like material science, and mechanical engineering, machine learning, and sensors, and electronic circuits, and etc. So with them, again, as I said, we have been trying to solve our business-related problems, and at the same time, to contribute to the quantum society, we are publishing papers. And the reason why we think this paper publication is important is that that's the only way that prove ourselves are valuable. So which means that there are one papers on the left side, which is ICML paper. We kind of always try to get paper accepted from the top tier ML society. So then we can claim that this technology and this finding is more valuable than the existing state-of-the-art machine learning algorithms. So that's what we have been claiming to. That's what we have been trying to do. So, well, including those kind of conference papers, we have published more than 30 papers. You can just probably Google and you can find those papers. And there are kind of some papers I listed in this slide. And so from the internal workforce perspective, there are some kind of things that I have to address first. So from the company in a corporate, quantum technology is recognized as very important technology for sure. And what we see is that the technology itself is kind of at the stage where a crucial transition is happening, and the transition is from quantum science to quantum engineering, and to achieve quantum utility in the near future, as I mentioned. And we are learning. It's from by practice. We are learning that quantum technology itself is a huge field, because it covers wide variety of platforms and technologies. Like if you look at the hardwares, there are superconducting, neutrons, photonics, and ion traps, and etc. So it covers almost everything. So again, well, as I said, since we have teams and they are working on some of those different kind of topics, so I asked them, what are the kind of challenges, what the challenges are, and what you feel as a challenges. And the answer from quantum CFD engineers is that they have to use algorithms and tools, which is fairly new. But they are based on the quantum mechanics, and that's totally different from what they have been exposed to. And which means that there needs a unique approach to secure and train specialized human resources for that. So same question I asked to material discovery engineers, and they said this: it is too difficult to calculate the properties of industrial meaningful materials using currently available quantum computer. And well, it is true. And the more important thing is that defining the problems. It is really critical to define problems to build really useful solutions for the company. And the quantum machine learning, well, actually those engineers answered really interestingly. They said that it's questionable whether quantum machine learning is competitive enough when compared to classical AI ML, which is kind of aligned with what Dr. Ju mentioned before my presentation. So which means that we have to hire the AI and ML expert to put into this specific project. I have been kind of interviewing candidates for this field, but the students currently studying in AI ML, they don't find any reason, a big reason, to work on the quantum machine learning part. So it's not attractive enough at this point, at least in Korea. And for quantum sensing, in corporate, probably in Angel Electronics, the majority of the workforce is not in the quantum physics or mechanics. They are based on material science, so chemistry, and electronics and computer science, and etc. So for those engineers' perspective, and when they are building quantum sensors or quantum systems, they find that these systems are so much integrated, and it seems like it's really difficult to understand everything for the experts who has different major. So they're having problems. But even with that, they studied a lot, they learned a lot, and companies, university helped a lot so that we can submit those papers like that. So actually, this is kind of interesting thing. So we did quantum. The whole team did Lego Serious Play in 2023. So it's something like a kind of methodology to facilitate kind of communication or critical thinking, etc. So we kind of like building Lego blocks using. We're building kind of future of our team or future of the quantum technology using Lego blocks, and you can see those entangles, right? Those lines that are representing entangles, and there's some like dots. Qubits, and there are systems as well. So they all build those kind of interesting structures, kind of using those kind of limited number of Lego blocks. It was really interesting. But one common thing here is that we found those kind of things, like dead bodies. I would say, like minifigures, the head of minifigures. They all use like most of them. They use those kind of minifigures head, and they explain that there need a lot of sacrifice. We need patience and something like that. So it's not an easy way to achieve this quantum technology useful from the corporate perspective. So takeaways and wrap up. So as I said, securing and educating special human resources is really important because we think this technology is really important. As a corporate research institute in quantum computing, as I said, I mentioned our objectives is to build a useful kind of output for our businesses, and that's why we are trying to identify the quantum computing that has significant business impact within companies, and to provide practice-oriented continuous R&D environment for accumulated capabilities. So that's why we are always looking into the opportunities for participating in national projects, because that's the kind of one of the way that you can get guidance and education from other experts. And as I said, despite the limitations of FTQC, we believe it may offer potential advantage in certain problems, and that should be more valuable than classic computers. So we need more workforce in the company, and those workforce, it's kind of system level kind of experts who are not only knowledgeable in the quantum science, but also knowledgeable in the system level. That includes all those kind of materials and engineering, the computer science, and etc. And the more important thing is that it's really to have experience on real problem solving with the existing classical computer environment, so that those people can help us and help kind of us to build a better quantum technology based solutions. Okay, so that's it. Thank you very much for your attention.
Just one quick question, again because of time limitation. Any questions?
Speaking of HPC, in the last slide, HPC expertise with the quantum talent is important. It is what the last slide says.
Right.
And currently, you might heard of Docker container or Kubernetes, that kind of, post virtual machine systems, right? So currently, we are making a supercomputing center, high performance supercomputing center, but as service getting smaller, and we are always saying that PaaS or SaaS, that for that HPC is getting is on the evolution to the container or orchestration field.
Right.
So in the transition from HPC to the orchestration, I think that I'm giving a suggestion that there might be the way that quantum talent can can get off power. I mean, quantum business can be made in that transformation era.
Thank you very much for your suggestion. Yeah, I do agree with that. Those kind of hybrid systems, orchestrated systems, we need both expertise for sure. But at this point, as I said, since those HPC system is already like well matured, and they are growing really fast, so in order to have really meaningful result out of the quantum technology, we have to understand what the limitation of the classical approach. So that if you like it's from our own like lessons, experience. Once you understand the limitation of the classical computer, then you can define the problems appropriately for the quantum computer. So again, yeah, we need both expertise for sure. Thank you.